last bit of theorems practice that we have. It's just 4 problems that I want to talk about. But remember, we have 5 theorems that we have to know. Only really need to know 2 of them by name, but we have the intermediate value theorem, the extreme value theorem, Rolle's theorem, and the 2 you really do need to know by name, the mean value theorem for derivatives, which is implied the mean value theorem for just mean value theorem, and then also the mean value theorem for integrals. This is a question that was actually on my BC test this year. But go ahead, just kind of as a warm-up, see if you can form an answer to this one. Again, this is the one topic where sometimes it's safer to be a little bit more wordy than you normally would. But go ahead and try answering this one for me. I tell you that you have this function p prime that is differentiable, and we have a table of that function. And then the question is, does there have to be a time t, with t being between 0 and 8, at which the pizza chain receives 300 delivery calls per hour? So go ahead and try that one, and I'll give you a second to kind of form your answer, and then we'll go over it. And then the other questions we'll look at, we have one that's just like the extreme value theorem, and then we are going to look at the 2 MVTs, where we actually have to calculate some stuff that has some equations to solve. Go ahead and see if you can write a statement or a sentence kind of describing your answer, whether that's going to be yes or no.
Is it continuous?
I tell you it's differentiable, so you would need to make some sort of statement of what you're concluding about that.
I want like a new one.
Oh, I didn't.
That button.
So you have to say that it's not a given, right?
You always have to say it no matter what.
Okay.
So yes, this one you would need to somehow find a way to clearly state that it is continuous and how you would know it is continuous.
Because it's like a reason why.
Part of your reason, yeah. There's my kind of answer for that one, and we'll talk about some other ways you could have worded this. What is in purple is what I would have to say in some form or another. The black stuff is kind of just like extra and wouldn't necessarily be required. The idea behind it is this is going to be the intermediate value theorem because we are looking for a missing value. And so if I'm looking at this table, I see that p prime is going from 5 to 450 and then from 450 to 250. So I know that at some point it had to cross over 300, somewhere between the 5 and the 450, and somewhere between the 450 and the 250. So technically it is crossing 300 twice at a minimum. but you would have to only really talk about it one time. And so when I'm forming my answer, Taylor, I'll get your question in a second, things that we would have to say at a minimum. So the intermediate value theorem, we never have to call it by name, but we do have to state somehow that it is continuous. And so it only tells us it's differentiable. So you have to have some sort of statement that says something like, since it's differentiable, it's also continuous. You can say a statement like, differentiability implies continuity, something that's linking, since it's differentiable, you know it's continuous. And then I chose the values of t is equal to 0 and 1. I know that at 0, p prime was 5, which is less than 300, and then at 1, p prime is 450, which is greater than 300, so let me fix that, which is greater than 300. So I have kind of shown that this is passing through 300, so I kind of said there is some c within that interval where p prime of c would have to be equal to 300. Now I couldn't have just chosen like 0 and 1, I could have used like p prime of 1 is equal to 450, and then I could have said p prime of 4 is equal to 250. And as long as you're kind of showing that there's some value like on one side of 300 and then the other side of 300, you're good to go. You would have to make sure you mention that kind of first statement that p prime is differentiable, so it means it has to be continuous. Taylor, what was your question?
So you have to mention that it's differentiable, you can't just say since it's continuous?
You have, yeah, so you can't just flat out say it is continuous. You have to say, you have to know why it's continuous and then state that in the given information. And so you would have to kind of add that statement, since it's differentiable, then it's continuous. Marcus?
Would you have to write the inequalities?
You have to show, you don't have to write it as an inequality, but you just need to have to somehow word it so that since you're at 5 and then go to 450, it had to somehow cross 300. So if you do that verbally, that's fine. I think the inequality is the easiest way to show that. But you do want to make sure it's kind of clear, like that's why I chose those two values, because one is less than 300 and then the other one is greater than 300. Armani?
For 2 questions. When you say like p prime is p, can you put t there instead, or does it have to be c?
It could be t and it would be fine.
Okay, also, instead of like putting p prime, I like where it calls per hour, which is what p prime is. Is that wrong?
For this, since we are talking about like a theorem of mathematics, you would want to name the function that you're discussing. Because calls per hour can really refer to a lot of things, so we want to specifically refer to the p prime that we're talking about for this situation. Caroline?
So, like, if I had said, like, since it is differentiable, therefore also continuous, and 300 is between p prime 1 and p prime 4.
That would be fine.
Okay.
So if you said, and for those at home who couldn't hear, Caroline said, so p prime is differentiable continuous, and p prime of 0, or what you said, 300 is between p prime of 0 and p prime of 1, that is fine. So as long as you're clear that that 300 is falling between two values, then you're good to go. Any other questions about that wording?
So you wouldn't have to say what p prime of 0 and.
Technically, no, because you are referring to it. You're saying p prime is 0. So you are referring it. I like saying p prime 0 is equal to 5, and that's why I picked it. But it's, as long as you are clear to what you're referring to, that's fine. And that's sometimes when I say these, like, yes, you can get away sometimes with saying like less words, but it's often just safer just to like you only have one chance to pass the AP exam. Like, might as well take some time to make sure you're like very clear about what your answer is, so you don't like lose the point that you really did know the answer for. So the remaining questions I have are not going to be ones that have a lot of writing. So I do have an extreme value theorem one. This one was kind of hard to come up with like a free response style question, because the extreme value theorem honestly often just shows up when you're talking about like a multiple choice question. So for these last 3 problems, I do just have this same function f of x, and we're just going to talk about f of x with the remaining 3 theorems, so you don't have to write down that. If you're using your own notes, you don't have to write down what's in that box multiple times. I will say I do state that this function f is continuous and differentiable. I technically could have left that off because f of x is a polynomial, and you should know that any polynomial is always continuous and differentiable. It's not going to have points of discontinuity or sharp returns or anything like that. Yes, David?
So if that equation was on the AP exam, would they still tell us it's continuous and differentiable or
If
not?
they gave you that equation, they may not tell you that's continuous and differentiable. They would just expect you to know that.
Okay.
And then before an answer, you would just say like it's continuous, but it's like a polynomial. But typically, they're probably going to put it in there just so you know for certain what it is. So how I kind of worded this is it's kind of based off of some of the homework questions. So I have that statement in bold, and it says f must have an absolute minimum on the interval from 0 to 2 with brackets around it. Would that statement have to be true or false? Must have an absolute minimum. It is true. And then how do we know it's true? And then I kind of already formed the statement after it. We know there's an absolute minimum because of the extreme value theorem. Which of course you are allowed to abbreviate EVT. And then what's the two requirements for us to talk about the extreme value theorem? It's a closed interval. So we have a closed interval. And what else is required for us to use the extreme value theorem? It just has to be continuous. So just the continuous part is the important part of that. And I chose this one mainly to talk about two things again. So what the extreme value theorem states is it states if you have a closed interval, meaning you have an interval that has brackets on the end, that you know without a doubt it has to have an absolute minimum and it has to have an absolute maximum. What the extreme value theorem doesn't tell you is it doesn't tell you where it is or what that minimum is. So then if I did change the interval, so for example, if we had an open interval, that could look anything like parentheses on both ends or parentheses on just one end of it. If you have those as your intervals, we do not know for certain whether it has an absolute minimum. It could, but we just don't know based off of the theorem. Either way, whether it's an open interval or a closed interval, if we did have to actually find the minimum, what process would you have to go through? It would be a candidates test. So like we're not going to do all this because we've reviewed candidates tests enough. But again, if you actually had to find it, like you're still going to have to go through like all the calculus. The extreme value theorem just tells you whether or not one is going to exist. And if you are doing a candidates test, just to review it a little bit, you would include 0 and 2, and then where the derivative is equal to 0. Yes, Ronnie?
For this question, like, how do you know that 2 or 0 and 2 would give you a minimum? Just like,
Well, we just know that there is a minimum on that interval. So it could be at 0, it could be at 2, or it could be somewhere between 0 and 2. We just don't know.
well, how did you establish the interval? Like, how did you pick 0?
It was just a problem given to you.
You just picked, okay.
Yeah. So that's the EVT. And then the last two theorems these are the two that actually have work that you often have to do. And that's the mean value theorem implied for derivatives. And then that's also the mean value theorem for integrals. So if you have to solve something, it's going to become one of these two. These are the two you also have to know by name because you do have to know the equation that is attached to their name. So the first one we have is the mean value theorem for derivatives. Again, I put that in brackets, but I could leave it off, and we would be implying that we are talking about the one for derivatives. What are the only two requirements we have to be able to use the mean value theorem for derivatives? Continuous and differentiable, which I think makes sense. If we're talking about the one for derivatives, we better have a function that is differentiable. And so I have, if f is continuous and differentiable, we can use the mean value theorem, and it tells us that there must be some c within an interval such that the derivative is equal to some number. And there's two ways they ask this question. If it's a one-part question, they're going to ask you like, what value would the derivative have to be equal to? If it is a two-part question, they will ask you, what is that value the derivative has to be equal to? And then what is the x value or the c value where that occurs at? So we'll just go ahead and do the two-part question just so you can kind of see what one would be worked out fully. The main thing that you have to remember, if you're doing the mean value theorem for derivatives, the equation we write is when the derivative, so f prime is equal to what thing? The slope. So it's when it's equal to the slope. I'm going to call that the average rate of change. And so if this is a one-step problem, you really just have to find the average rate of change, which the average rate of change is just that old school slope formula, the change in y over the change in x. So I have the interval, and again, it would be provided to you, change in y over the change in x. I'm just going to go ahead and use my calculator to find this. So f of 2, 5 plus 2 minus 8, negative 1. Minus, that's going to be 5 minus 1 plus 1. All over 3. Negative 6 divided by 3 is negative 2. And that would be like maybe a one-step problem. They could just stop the problem there. They would say, hey, what value of the derivative will we be looking at? We will be looking for the time the derivative is equal to negative 2. A two-step problem would ask you to go further. Because again, what the mean value theorem for derivatives states is it basically says we have this function. Between 2 points, we have a slope. So we have a slope at negative 1 to 2. And this has a slope of negative 2. We want to find at what x coordinate does the tangent also have a slope of negative 2. So this is a second step problem. Then you would basically find the derivative and set it equal to that slope you found. Well, what is the derivative? We can find that pretty easily. 5 goes to 0, x goes to 1. Minus x cubed becomes 3x squared. And we want to find when the derivative is equal to the slope of the secant line. And then we just want to solve it. I get x squared is equal to 1. So x would be equal to plus or minus 1. So basically that c value we're looking for is plus or minus 1. How does that make sense of the problem? So like, I tried to draw a pretty accurate graph of what it looks like. That basically means that when x is negative 1, the tangent also has a slope of negative 1. And when x is positive 1, the tangent also have a slope of negative 2. Excuse me, I said negative 1, but I meant negative 2. So we have found in this case 2 points where the mean value theorem for derivatives is satisfied. Evan, you had a question.
Yeah, so like in the last problem, we said it gave us differentiable or whatever. So we said because it's differentiable, it's continuous. So why do we have to say like continuous and differentiable?
So
Just say differentiable.
Good question. So you want to say both because I don't have a good answer for it, but because the requirement of the mean value from derivatives requires it to be both clearly. So like you could say like, hey, it's differentiable parentheses, which means it's continuous, but you will want to say both. Like clearly it can't be differentiable and not continuous. That's not a thing. But you do just want to say both of them because they are both technically requirements for the theorem to work. Yes, Armani?
How come we're doing like the plus minus again?
The plus,
When you square root.
because that's what I do when I take the square root.
But sometimes we don't.
That's one way to say that.
Yeah, that's when we have like like if this interval had been like just from 0 to 2, then I wouldn't do plus or minus, I wouldn't care about negative 1. But plus or minus 1 falls within that interval. Yes, negative 1 is the endpoint, but it still falls within that interval, so I want to include it. But if I had an interval that, say, started again at 0, 2, I would only care about the plus 1. questions on MVT for derivatives? Again, main thing you want to remember, because it comes up a lot, as in I know it's going to come up Wednesday on your test, is you have to be able to set up an equation when is the mean value theorem for derivatives. And the equation we're setting up is the derivative equal to the average rate of change, or basically the derivative being equal to the slope. Then the last one that we have, pretty similar, you can probably assume where we're kind of going with it. Same function, but it's the mean value theorem for integrals. Again, it will have to tell you for integrals if that's the one that you're talking about. The integral one only requires your graph to be continuous, since you aren't taking a derivative anywhere. It doesn't matter if it's differentiable or not. And the mean value theorem tells us that there must be some c such that f of c, so again, not f prime, but where f of c is equal to something. And again, it could be a two-part question. Sometimes they ask you just to find the value that is equal to. Sometimes they ask you to take it a step further to find the c value that gives you what it's equal to. So the mean value theorem for derivatives, you set the derivative equal to the average rate of change. The one for integrals, what are we setting it equal to? The average value. And again, that's going to be like the main equation format you want to remember. Average value we know is 1 over b minus a times the integral from a to b of your function. You could find that integral by hand, like the antiderivative of 5 plus x minus x cubed is pretty easy. Go ahead and just find it in the calculator, just so we don't take too long doing it. But find it in your calculator for me. And that would be kind of like the first step to this problem. And then the second part, when I do want to see the calculator, is that we end up getting an equation that we can't solve by hand. Sometimes you can, sometimes you can't. So let's go ahead and find that antiderivative. And of course, I'm cheating because I did it in fourth grade already. Again, you can type it in separately, or then just type in the integral and then divide it by that b minus a. But we do see that the average value is that 4.25. And that is the first part to it. Sometimes the question might ask you just to stop there. Hey, what is the value that you're looking for that f prime of c would have, f of c would have to be equal to? To take it further, it might say, hey, find the c value, find the value of x that makes that equation true. So the equation that we will be solving is when the function is equal to the average value. Biggest mistake I see with this is some students try to do when the derivative is equal to the average value, but again, we're doing when the function itself is equal to the average value. Sometimes this becomes an equation you can solve by hand. This one, you can try, but it's not factorable. You can't solve it by hand. We do have a calculator, so we can solve it in the calculator. Two ways to solve it. You can either graph it and find an intersection point, which is my preference. This one, though, is a simpler equation, so you can use the numeric solver built into your calculator as well. I'm going to find the intersection point only because I like what it looks like when you graph it. So I have my function in y1. I have the average value in y2. Zoom 6 will give you a window, and as long as you see the intersection point, that's fine. I'm going to zoom mine in a little bit since I'm just looking at the interval from -1 to 2. And I'm going to make my y values a little bit smaller as well, but that's not going to be required. Again, there's other ways to solve it as well. You can use the solver built into the calculator as well. There's the graph of it. I do like looking at the graph before we actually solve it because it helps remind ourselves what average value actually means. So that blue line is the function f of x, and that red line is literally representing the average. If you could go and imagine that blue graph made up of a whole bunch of coordinates of y, and if you could add up all those y coordinates and then divide it by the number of y coordinates you have, Where that red line is literally the average of that function. Why it's so high on the function, I think it kind of makes sense. I might describe this as like, I don't know, a senior who makes all A's the first 3/4 of the year and then craps out the last 25% of the school year. So their average is still pretty high, but you can see where it kind of drops. So we see that the average value is fairly high up on the graph. What we're looking for and what the mean value theorem for integrals states is that at some point, the function and its average will be the same. We can visually see, yes, that happens one time. It can happen more than one time. I want to find that one time, so I'm going to go ahead and find the intersection point. Yes, that's my first curve. Yep, that's my second curve, and a guess. So I see that the x value or the c value is 1.262 or 1.623. Either would be acceptable. And that would be the c value that we're using, or x value. And either of those answers would be allowed.
It doesn't matter if you put C or X.
It doesn't matter, so you could put C or X, and honestly, the AP exam will give you credit for either, since C is an X value. So again, big idea that I want you to get from that though is like, what is the equation you set up? If you're talking about the mean value theorem for integrals, the equation you're setting up is when the function is equal to its average value. If you don't get anything from that slide, that's what I want you to get from that slide. If it's the mean value theorem for derivatives, the equation is f prime is equal to the slope formula, or f prime is equal to the average rate of change. Yes, Taylor?
So if you get that first number wrong and you use it in the second one, do you only get points off in the first?
You would get only points off for the first one, yeah. Any other questions about these theorems? Yes, Evan.
So just another context question. So the B/C because thing, is that acceptable in the
So any abbreviation that is pretty much accepted by most people is okay.
Okay.
Like you just want to think about like some random teacher, professor grading your exam.
So they'll know.
They should know what because is. Like don't just make up abbreviations for everything.
Yeah.
But yeah, any common abbreviations are fine. Like when I was grading the AP exams this summer, they pretty much told you like, if you could read it, then like, grade it. And even if we can't read it, and if people are using like weird abbreviations, like we have like an international student and they're using stuff we're not familiar with, like there's people who we send the exam to and they grade it and stuff.
Oh.
So like, there's someone who can probably grade it. They even have people who can like, if we had a paper we couldn't read because the handwriting was so bad, they hire people who are handwriting specialists to grade just those exams.
That's funny.
So yeah, they have like, they're gonna find a way to grade it unless it's just like a picture or a poem.
Okay.
So that's basically it for the unit. I do want to kind of tell you what my plans are for the last 2 days on Monday and Tuesday. So your test is on Wednesday. I'm hoping that like since you had the quiz, like you're feeling a little bit more comfortable with kind of just like looking at these problems and interpreting them, just to get used to kind of reading them. My plan for Monday, I shared it with you. You can see it in OneNote, but it's basically like some massive long word problem. It is about toilet paper flying off the shelves, but I figured that kind of fit for what happened basically a year ago next week. So that's how we'll do basically on Monday. But basically Monday and Tuesday will be a day for us to review, practice, you working on homework, your briefcase binder, and getting ready for your test on Wednesday. Looking at the rest of basically the year, basically, what am I trying to say? The year. So we're here, like your test is next Wednesday. We literally have like 2 units remaining. We have unit 8, which is fairly short and also fairly easy. And then we have unit 9, which is also going to be fairly short as well. There are gonna be like a lot of crazy things happening between now and finishing. Like, on March 30th, that's the day that juniors are taking the ACT, and like, I had mixed classes, that's just gonna be like, nothing planned that day. The county is planning some like mass vaccinations of teachers, those weeks shaded in dark gray. Depending on how many teachers will be out getting a vaccine, they have already told us, we got an email from the superintendent last period, that some of those days will most likely be virtual, just because there will be a lot of teachers out and just kind of managing that whole thing. I don't know anything more than that, but just told that some of the days that are shaded gray would be virtual. And my plan is to finish teaching everything that Friday after spring break, and then we would have 2 solid weeks plus a day to review from the AP exam. And in all honesty, if I end up having to push that test back to that following Wednesday, a week and a half is honestly enough time to review for the AP exam. I'm not one that's really big on needing 4 weeks to review because that's just excessive. And we'll be doing plenty of review as we get closer and closer to the AP exam. Last thing I'll say, Fulton County Schools is saying that students can take 2 options for the AP exam. So there's going to be the traditional 2 weeks in May, and that's the one that I'm going to encourage you to take. It will be the traditional, like, pencil to paper AP exam. The other administration window that the county is letting students take is the 3rd one that College Board is offering, but it is not until the 1st and 2nd week of June. So it would be over the summer. It would be digital, but it would still be that same 3-hour and 15-minute exam. So it's not going to be like the exams they had last year. And I'm just going to be honest, like, I am not helping you review this last bit of May, so it's kind of on you if you do choose to take it in June. There will be, however, a survey that comes out, and basically you will be able to like say, like, I plan on doing the in-person one, or I plan on taking the digital one in June. But once you make that decision, you're pretty much locked in with what you're doing. Brett.
I know for English, there's like differences between in-person and online. Is there in this?
The only thing we've been told is like it's still going to be the same. We'll have multiple choice and free response, and it will still be the same time length. So I imagine they're going to be pretty much the same. I do know they'll probably do some different questions. Because I know for the calculus one last year, they wrote questions that were pretty much like there wasn't a lot of like find the derivative, find the integral, because you can kind of look up those. So they were questions that were written in a way that looking at notes wouldn't help you too much. So personally, I think the in-person one would be the better one to take because it would have more skill-based questions in it than a whole bunch of like application questions. Marcus?
Are we gonna have files in this class?
There is a final, but I'm hoping everyone takes an incomplete for it. Please take an incomplete for it. Taylor?
I think it was Miss Chilton, I'm not sure, but she said that there wasn't gonna be any, like, you can't post pictures to it, so you have to like type in the.
That too. So I don't know if they're gonna change that, just because of